Okay. So our big two, everything when we do these trig functions, the identities and simplified, we want to try to get things in terms of sine or cosine. And then once we're done simplifying, we can convert it back to, if we need to, one of these other type functions. So those are the big two. You should have already at some point learned that cosecant is just a reciprocal function of sine. So cosecant and sine, they go together as reciprocals. 1 over sine is cosecant, and secant goes with cosine. And that's, again, a reciprocal function. 1 over cosine is secant. Tangent comes from dividing sine divided by cosine. So we can always write tangent instead of sine over cosine. And cotangent is the reciprocal, so it's cosine over sine. And then there's this major Pythagorean theorem. We're not going to show how we get into it, but it's the idea from a triangle. And you know, sine and cosine, there's that opposite, adjacent, hypotenuse. We're not doing all that, but it's just like a squared plus b squared equals c squared. And if you remember, at some point you had a unit circle, and the radius of that unit circle is 1, and that's your c. And then you learn that the y value was your sine, and your x value, so it's like doing x squared plus y squared equals c squared, and that's 1. But this identity, sine squared plus cosine squared, always equals 1, can be converted. So if you subtract sine squared to the other side, it'd be 1 minus sine squared equals cosine squared, or the other way around if you subtract the cosine squared. So all of these are from the same identity. So if you see these type things in your problem, you know you can convert them to the other one, and you'll see when we get onto that. So here's your first example. And all it is, it's going to be, like I said, it's going to be a trig expression that you're just changing it to try to simplify it. And the first thing I always do is change them to fractions and change them to sine and cosine. So if you look back at that first page, cotangent is cosine over sine. And then sine, if it's just sine, just do it as sine over 1. If you have expressions that are the same on top and bottom, you can always reduce them out. Sine and sine would cancel out. So in this one, all you're left with is cosine over 1 or just cosine of theta. So that's what this one would equal. So pretty simple. If you just have expressions, turn them into fractions. All right. So same thing. Sine times secant of theta. So you would, if it's just sine, write it as sine over 1 as a fraction. Secant, that's the reciprocal of cosine. That is 1 over cosine. There's nothing that cancels out. So if we just go straight across, sine times 1 is sine. 1 times cosine is cosine. And then don't leave it in that form because you want to write these as one trig, but sine over cosine, that's tangent. So this would equal the tangent of theta. If there's fractions, you have 3 trig terms. So I'm going to do 3 fractions for each one of them. The ones on the top, I'm going to do just like I did the last ones, right? Cosine is just leave it in terms. Everything's going to be either cosine or a sine. So cosine would just be cosine over 1. Tangent, you look at sine divided by cosine. So that's my tangent. Cosecant is 1 over sine. But since it's in the denominator, I have to do the reciprocal to write it as a fraction just with these. So 1 over sine, I would write as sine over 1 because it's in the denominator. So anything in the denominator of the fraction gets flipped over to right in line. So now, okay. So now anything that's in these, I have a cosine numerator, denominator, so those are reduced down to 1. If you have 2 of them, you write that as sine square theta. You put your square there. They're not adding, so it's not 2 times, it's sine times sine, so it's sine square theta. It's the same thing as sine theta squared, but we don't write it as sine of theta squared because you can't tell if that's just the theta that's being squared or if that's the sine that's, so don't write it like that. Bad. Put the 2 before the theta. And that's it. That doesn't reduce to anything else. That's the answer. Sine squared theta. So if you have 2 of them being multiplied, just write it as squared. 3 of them would be sine cubed theta. As long as it gets down to just 1 trig word. So the tricky part is making sure whatever's in the denominator, change it to a fraction, and then reciprocal. Do the reciprocal of that fraction. Flip it over. All right, so when you're adding, let's first change this to all fraction stuff. So cosine would just be cosine theta over 1 plus tangent is sine theta over cosine theta. Sine is just sine theta over 1. Right. To be able to add 2 fractions together, you have to have common denominators. Make sure you have common denominators. So I can't add these as it is. To be able to add it, this one has a cosine on the bottom, this one does not. So I need to put cosine in the denominator, but I can't just put cosine of theta in the bottom. I have to also put it on top because that's really not changing anything, right? I could just cancel those out. So both of them have to be in there before you can add them together. Now I can add these 2 together. Well, cosine is cosine squared theta plus sine is sine squared theta over, now my denominators are the same, cosine times 1 is just cosine. Remember, when you add and you have like denominators, that denominator doesn't change, right? And you don't add the denominators together, you just leave it as that common denominator. Well, that's our Pythagorean theorem identity. It doesn't matter if I do sine squared plus cosine squared or sine cosine. Either way, it equals 1. So cosine squared plus sine squared is 1 over cosine theta. And now I'm down to 1, but I don't leave it as a reciprocal. I write that as cosecant. Oh, not cosecant. Oh, let's do that. Maybe I'll be able to do that quicker. Probably not. It's gonna take forever just to get rid of that. I'm just gonna scratch that out then. Okay, so 1 over cosine is secant theta. That's your answer. So change them to fractions, change them to all sines and cosines. If there's addition, you have to have common denominators. Create that by multiplying top and bottom of whatever's missing, then combine and reduce. All right. So number 5, back to just one fraction. So I have 3 terms, so I'm going to do it as 3 different fractions. Cosine, like I said, everything's going to be in terms of sine or cosine, so I can leave cosine. Cosecant is 1 over sine. Cotangent is cosine over sine. But then, since it's in the denominator, I'm going to flip it over. So I'm going to multiply by sine over cosine. I have a sine on top and bottom, cosine on top and bottom. I have nothing left but this equals 1. So sometimes it will just come out to a 1, just a constant number, no trig at all. Maybe it'll come out to -1, maybe it'll come out to 0. Okay, again, you're adding. So 1, which I know it, just change it to a fraction. 1 over 1 is 1. Cotangent squared is the cosine squared. So anytime it's a squared function, you can just write it with squares, even when you change it, over sine squared theta. To be able to add these two together, I need common denominators. So this is missing a sine squared. So if I do a sine squared on the bottom, I have to do sine squared on the top. Now they would be the same, so I'd add them together. Sine squared theta plus cosine squared theta all over sine squared theta. That's that trig identity, which equals 1 over sine squared theta, which 1 over sine is cosecant. So this would be cosecant squared theta. So again, when you have addition, you have to make common denominators with those. We can turn everything into sine and cosine. All right, so same thing, subtraction, you're still gonna have to have common denominators. Secant is 1 over cosine. So secant squared would be 1 over cosine square theta minus 1 over 1. That has cosine squared theta, so this one needs cosine squared theta in the denominator. And it needs it in the numerator, so it's not like doing anything new, right? So this would be 1 minus cosine squared theta over cosine squared theta. And this is also on our trig identity. So if you look back at those first identities I showed you, 1 minus cosine squared theta is sine square theta over cosine square theta. And sine over cosine is tangent. Since it's squared, you just tangent square theta. Common denominator. Subtract them. Know that identity. 1 minus cosine squared is sine squared. 1 minus sine squared is cosine squared. Right, so that times, just showing you they're being multiplied. So I still have 1, 2, 3, 4. They're all being multiplied. So I'm going to write them out as 4 fractions. The tangent that's in the top, I'm just going to write normally sine over cosine for tangent. The rest of them are denominators, so I'm going to have to do the reciprocal. Cosecant, which is 1 over sine, I'm going to have to write as sine over 1. Sine, which is just usually sine over 1, in the denominator would be 1 over sine. Secant, which is 1 over cosine, since it's in the denominator, I'm going to write as cosine over 1. So I have a cosine on bottom and on top, sine on bottom and top. All I'm left with after all of that is sine theta. And that one's done. So even if it's a multiplication in the middle, it's still just all fractions being multiplied with each other. Reciprocal of the denominators. Can't stress that enough. That's where most people make their mistakes. So don't just change them to fractions, but also reciprocal. So this is addition. So this can be 2 separate fractions, right? Tan is sine over cosine. Cotangent, which is cosine over sine, is in the denominator, so it flips over. So it's also sine over cosine. Plus, you have cosine over 1. Secant, which is 1 over cosine. And so 1 over cosine. So to kind of clean this up, we're going to need this cosine anyhow, but this would be sine square theta over 2 cosines would be cosine square theta plus, I could reduce this out, but I need to add them together. I need cosine squared, right? So I already have 1 cosine. I need another cosine anyhow. So no need to reduce it out. I need both. So this is cosine times cosine would be cosine squared over cosine square, which of course that would be 1. But to add them together, I need the common denominators. Sine squared theta plus cosine. You don't have to write that over again. By now you should know that's 1 over cosine square theta. And then the 1 over cosine is secant. And since it's squared, it's just secant square. So common denominator, writing them as fractions, all sines and cosines, sounding redundant. One more example I believe there's only 10. So we're subtracting. So again, write it as a fraction. Tangent is sine over cosine. Cosine in the denominator would just stay cosine in the denominator. Right, because cosine is cosine over 1, so flip it over. You put a 1 on the top if you want, minus secant is 1 over cosine. So this would be 1 cosine. Cotangent is cosine over sine. It's in the denominator, so flip it over. That'd be sine cosine. So this is sine of theta over cosine square theta minus sine of theta over cosine square theta. Well, sine minus sine, like those are the same, right? You subtracted them, so that's 0. That just equals 0. Those two expressions are the same when you simplify them. So if you subtract them, you just, nothing. I think that's it. Yep. All right. So let's